Welcome to Vigyan Academy. In solid state, this is our second lecture. In the previous lecture, we have discussed about the factors by which the states can be governed and state can be defined. Today we are going to discuss about the type of solids. In type of solids, when we talk about type of solids, they can be broadly classified into two categories. First is crystalline solids and another is amorphous solid. Before discussing about the differences between crystalline and amorphous solid, we should know and we should observe the things and the substances around us. Just to understand the basic concept, the point of differences between these two solids. You just take sugar in your palm and you can take powder on your another palm and just feel it. You just feel it. When you try to feel it, you just can say that sugar is having a specific geometry of their particles, but there is no such type of specific geometry is found in plastic, in glass, in powder. So the powder like substances, the powder like solids are termed as amorphous, while the crystalline solids are having the definite geometry of their particles. So now we can understand their differences. What is the first difference between the crystalline and amorphous solid? That they have definite arrangement of constituent particles. Their constituent particles, the particles that is going to make that particular solid, they are definite arrangement. They have well arranged structure, while such type of arrangement is not found in amorphous. So when we are saying that they are having the definite arrangement of constituent particles, so we can say that they have definite geometry, because geometry is decided by the arrangement of the constituent atoms. So when constituent atoms are definite arrangement, are having the definite arrangement, they are well arranged in their structure, so we can say that they have definite geometry in the case of crystalline solids, while such type of geometry remain absent in amorphous solid. Now talk about the third point, that fixed and sharp melting point in the case of crystalline, but they have a range of melting point, not sharp melting point in the case of amorphous. So when you talk about sodium chloride, when you talk about any other crystalline solid, they have sharp melting point. If I say that this solid melt at 128, then whenever the 128 degree reaches, it start melting. So it states the sharp melting point. But such type of melting point sharpness is not found in the case of amorphous solid. Now, talk about the fourth one. The fourth point of difference is when you cut the crystalline solid, you will get a smooth surface, while such type of a smooth surface remain absent in the case of amorphous solid. When you cut with knife, when you are cutting with knife to crystalline solid, it gives the smooth surface, definite surface, because the geometry is definite, the arrangement is very well arranged structure, so they give a smooth surface, while rough and irregular surface is obtained in the case of amorphous solid. Now talk about fifth point, that is anisotropic in nature. Crystalline solids are anisotropic in nature. Anisotropic we are going to discuss in our next lecture. So anisotropic, crystalline solids are anisotropic, while amorphous solids are isotropic in nature. What is anisotropy and isotropic? Don't worry, I am going to discuss in my next lecture. Okay, now the last point is between the crystalline and amorphous solid is that crystalline solids are having the definite geometry, definite arrangement, definite melting point. So whatever we observe and whatever we feel that is found, that should be found in solid, these all properties are possessed by this particular crystalline solid. That's why they are termed as true solids. Why? Amorphous solids are called as pseudo solids, or in simple way, in general way, they are termed as supercooled liquid. Why they are called as supercooled liquid? Why glass is called as supercooled liquid? These all questions will